Welcome to Web Handling. My name is Dave Roysam. I am super excited to continue our new mini-series on machine speed concerns. In this week's show, we discuss applications for dual drives, including two-drum winders, center surface winders, and finally, calendars such as might be used for laminating. We also discuss the many costs and why those costs might be worth it in some cases. Note that this show is a bit geeky, so if that is not to your taste, we have a new series beginning shortly that should interest most everyone. In any case, I know your time is precious, so let's get started. In draw control that we discussed last week, you might have two motors loosely connected via the web in its traction with its rollers. In a dual drive system, two motors are coupled much more directly. Applications include winders and calendars. This is obviously quite expensive to do. First, there are the costs associated with both the motor's mechanical and electrical. However, as my students will recall, you only pay those costs once. I am much more concerned with another cost area. That is, the cost of complexity, because you pay those costs every day of every year that the machine runs. What benefit might you accrue? And how would you program those motors to do that? And what limits does that strategy have? Well, the short answer is that by using two motors instead of one in a dual drive configuration, you can sometimes extend the range of certain processes, such as certain winders and certain calendars. As my Web 101 students will recall, a winder's class determines which of the TNT knobs are available that can adjust wound roll tightness. If you have just a center winder, you only have the tension knob to work with. If you add a nip, you can extend the range of tightness at the upper end. Finally, if you add a second motor, you have a center surface winder, and that can extend the range at the upper end even more. So, if you need more tightness and the tension and the nip knobs are already at maximum, you might get a bit more tightness by adding a second motor, making it a dual drive system. Much more about wound roll tightness can be found in the advanced winding sections of Web 101. Observe that an older and more common dual drive winder is found as a standard in paper mills. That is, the two-drum winder. Here we have a motor connected to the back drum, that is the master speed. The front drum is running as a torque difference, and it can be either in the motoring or braking direction. However, instead of running a single set point, the front drum motor is usually programmed to go from motoring at the core to braking or regenerating at the outside, for similar reasons that you might use taper tension in converting. The important takeaway is that by adjusting the torque split differently, you can add or subtract tightness already coming from tension and nip. Note that the total torque remains constant. Only the split changes. Note that there is no difference in principle between the two dual drive winder types discussed, even though they look quite different. See Web 101 for additional details. The mighty paper industry tried for decades to gear the two elements together to simplify the system and eliminate the cost of one motor. However, there were so many limitations that approach was abandoned most everywhere, except for in textiles. One limit was that direct gearing, such as a 1-to-1 gear with a tiny drum diameter difference, is not adjustable. Another limit is that to get meaningful gear ratios, the difference had to be exceedingly small, as the calculation shows below, for stiffer materials. To get small but adjustable gear ratios required a harmonic drive, and those mechanical drives are more expensive than two motors. And the harmonic drive required a second small motor anyway. So what happens if your gear ratios are notably higher than, say, the example shown here? The answer is you'll break something, depending on the details. That something is either the gears, the web, or traction. Laminator curl is one of 6 totally different types of curl, but is a super serious issue for some in any case. This specific type of curl is the result of a mismatch in strains between two plies as they enter the nib. See Web 101 for details. However, as we learned in class, the strains entering the nib are not only the result of incoming tensions that you have some control over, they also are the result of many other material properties that you have little or no control over. The net result is that laminator curl is highly over-constrained. That is because we may need to achieve as many as 8 goals just listed, but we only have 2 knobs to achieve those 8 goals. Of course, you could do trial after trial to see if you get better results. However, I think you'll have a much better understanding if you review the physics of laminator curl, which are well documented. Curl management begins with education of all the groups involved, such as by signing up and taking my Web 101 class. We could begin at the beginning by teaching product developers how to use the principles of DFM, Design for Manufacturability, to find suitable alternative materials that have closer MD moduli. We could also teach operators how to more aggressively reduce the tension of the low modulus ply, knowing that increasing the tension of the high modulus ply, while in the right direction, will be mostly or wholly ineffective. That leaves product, process, and/or machine redesign and decurling. To make a very long story short, we can add dual drives to the laminator to function much like the 2 drum winders types we discussed earlier, to extend the range of the machine. As you might expect, dual drives are not only expensive, they are complicated. While this is not the place to teach design, I want to at least give you an overview of the major points. So the first thing we need to do is to size the motors. As shown in this generic example, we want the motors to fight each other because that's how we get more dual drive work done. As such, you might have 4 times the amount of connected power in a dual drive system as in an equivalent single drive system. As such, we may be regenerating on one of the motors while the other is motoring much more than it otherwise would do in a single drive configuration. The next thing we need to do is to select a control strategy. While one motor would be in either master speed or tension control depending on the system, the other is always in torque control. In the case of calendaring, the set point torque split is adjustable but fixed for a particular product run. In the case of dual drive winders, the torque split will be programmed as a function of current wound roll radius, much like taper tension and converting. I hope you've enjoyed this discussion of dual drives used on certain web machines. I know this was a bit rushed and lacking details, but I wanted to give you an overview of the costs and benefits of considering the dual drive approach. However, like many things, the devil is in the details, and you really should go to school on this before you go out and spend money for a second motor or struggle with how to use a second motor if you already have one. If you have a topic you would like to hear about, let me know in the comment section below. If you found anything interesting or useful here, please like and share and subscribe. See you next time.